It's essential for learning and the consolidation of memory. Recent studies show that in humans, a too energy-rich diet also interferes with the hippocampus.
We see, for example, that the quality of people's diets is related to the size of their hippocampus, to the size of their grey and white matter volume, and there's starting to be intervention studies. So, for example, we see that only 4 days on junk food type diet will have an impact on cognitive functions that are related to the hippocampus.
Margaret Morris is now seeking to understand how sugary and fatty food disrupt the brain of her rats to the point of affecting their performance. She has a hypothesis, namely, eating too much fat and sugar triggers an inflammatory reaction that spreads to the neurons.
So, in response to these foods, there's a general inflammatory response all around the body. This has been well described in obesity, but it now appears to be quite an acute response as well. And what we find is that inflammatory molecules such as cytokines are increased in response to the diet.
An overly rich diet infuses the immune system. It responds by triggering an inflammatory reaction, especially in fatty tissues. Our fat masses release substances that then propagate this inflammation throughout the body. Neurons were thought to be spared this effect behind the protective blood-brain barrier, the semi-permeable membrane that separates the circulating blood vessels from the brain.
So there's increased inflammation in the whole of the body, and we think that this may spread to the brain. That's because the blood-brain barrier, which normally protects the brain from inflammatory molecules, may be impaired, in fact, by the diet and become leaky, allowing traffic of molecules into the brain.
The inflammation infiltrates the meninges and then triggers a surprising phenomenon. In her laboratory, Sophie Ley has shown in her overfed mice that certain immune cells in the brain, the microglial cells, begin to devour neurons.
These microglial cells within the brain are important because they can eat dead neurons. But when they're deregulated, especially in a situation of unbalanced nutrition, they start to eat neurons that are alive. Therefore, by consuming these neurons in excessive numbers, eventually they will destroy or participate in the destruction of neural networks. That includes neurons that are alive and that should be functional.
This reaction of the microglial cells could be filmed in vitro. The images show how energetically they move. The red objects are fragments of neurons that they ingest. In an obese mouse, the activity becomes frenetic,